Our focus in this video will be 2 by 2 matrix determinants. Last video we looked at 2 by 2 matrix determinants. Now we are going to look at 3 by 2 matrix determinants. There's just a few things that are different about 3 by 2 matrix determinants, so pay close attention. So given that matrix B is B11, okay, look at the entries of matrix B. To get the determinants, we're going to bring out plus B11, and then we get a 2 by 2 matrix in determinant form. Same thing here. So how will you arrive at this point? First of all, let's come to this side. So if you look at it critically, you discover that the first row was factored out. First row B11 is here, B12 is here, B13 is here, and then we have 2 by 2 matrix in determinant form. And then there are signs attached to each of the factored entries. So how do we arrive at these signs, and why do we have it like this? Generally, this is the format on how to go about finding the determinants of a 3 by 2 matrix. Let's look at the signs first of all. How we got the signs is that the sign attached to B11, B12, and B13 on and on is given by the chessboard format, where you have a plus, minus, plus, and then the next row minus, plus, minus, followed by the next row plus, minus, plus. So start with plus, then end with plus. You start with minus, you end with minus. You start with plus, you end with plus. Now another way to get these signs is this rule: -1 raised to I plus j, where I is row, as the row of the matrix, and j is the column of the matrix. If you locate the exact point where the matrix, the entry is, you're going to look at the row and the column. Where that intersection meets is where the entry is. For instance, B11, the entry of B11 is the first row, the first column. So the first one, the first column meets here. So this B11. To get the sign there, the rule is that since it's 1, 1, -1 will be raised to I, -1. So the first row, the first number signifies the row, the second number signifies the column. So 1 plus 1 -1 raised to power 2. So -1 raised to power 2 means -1 times -1. And that will give us minus times minus is plus 1 times 1 is 1 plus 1. So our sign here for the first entry is plus because of the position of the row and the column. So looking at the second one, B12, -1, 1 plus 2. This will give us -1 is power 3. This is -1 times -1 times -1. Minus times minus plus, plus times minus is minus. 1 times 1 is 1, times 1 is 1, so -1. So our next sign here is negative minus. So check, let's try B22, B22, oh, -1, 2 plus 2. And that will give us 2 plus 2 plus 2 will give us 4, -1. Give us 4, -1 times -1 times -1 times -1. So minus times minus plus, plus times minus minus, minus times plus. Minus times minus is plus, plus times minus. Minus times minus is plus, minus times minus is plus, plus times plus is plus. 1 times 1 is 1, 1 times 1 is 1, 1 times 1 is 1. That will give us plus 1. That's why we have plus 1 here, and then we have plus 1 here. So B21 -1, 2 plus 1 is 3, -1 plus power 3, and this is -1 times -1 times -1. Minus times minus is plus, minus, so plus times minus will give us -1. So our entry here, the sign is negative. So either you follow this rule or you follow the chessboard format. Then, as a rule, to determine the determinant of a 3 by 3 matrix, you could start with the first row, just factor out the first row and follow the signs, attach the signs to the row you are sticking to. If it's the second row you want to use, you have to factor out. Then this will be minus b21, you factor it out, and then you get this 2 by 2 matrix in determinant form. And then you look for the determinant of the 2 by 2 matrix multiplied by the factored row, the entries of the first row, either the first row or the second row. As I mean, this is what I trying to explain. Let's say given matrix E is equals to, so I'm saying that these are given matrix E11, E12, E13, E21, E22, E23, E31, E22, E33 is the given matrix. So to look for the determinant of this 3 by 3 matrix, as a rule, you attach the signs to the row you want to factor out. So let's say you want to factor out the first row. So I'll attach our signs here, plus, minus, plus. So factor the first row out. This will give us equals to plus E11, whatever the value of this entry is what you are going to write here. Then we'll look for the determinant of the square matrix that you're going to get here, or the 2 by 2 matrix rather that you're going to get next from what we're going to do. So what we're going to do next is that since we factor out E11 out, so what that implies that the first row and the first column will be eliminated or obliterated to cover it. So what will be left is these 4 entries. So these 4 entries will form our 2 by 2 matrix of this E11 that has been factored out. E22, E22, E23, E23. You bring it down. So at the end of the day, you have E11 out, and then you have a 2 by 2 matrix formed. And in this form, it's like they're evaluating the determinant of this 2 by 2 matrix because of these truths. Same thing applies to the next one, minus A12, A12, and you find the determinant. So for this, in this particular case, you're going to strike out the first row and the second column. So you're going to have A21, A21, A31, and A23, A23. So third one plus A13 plus A13, and this time around is the first row and the third column. So these 4 entries are going to the left. So you pick them A21, A31, A22, A32. Of course, when you get to this point, you know what to do, because the last video we looked at how to determine the determinant of a 2 by 2 matrix. So you look for the determinant of these 2 by 2 matrices and multiply it by this factor, or what will now look like a scalar multiplication. And this is exactly what this part means, because at this point we're looking for the determinant of this 2 by 2 matrices. That's what you have in here, multiplied by the scalar which was factored out, attached with the signs attached to the scalar, which this row that you have here. So this is how we go about determining 3 by 2 matrix. I think the examples that we're going to take subsequently will show how we do this practically. Here, find the value of this matrix 0, 3, 2, 1, 7, 8, 0, 5, 4. Anytime you see entries enclosed by strokes. It tells you that you should look for the determinant of that matrix. So whether it's 2 by 2 or 3 by 2, once the matrix is enclosed by 2 strokes, it tells you that you have to look for the determinant. So in this case, we're going to look for the determinants of this matrix. So let's attach our sign. This 0, this is plus minus 2, this is plus 0 plus 0. When you have, if you're eliminating this part, you're going to have 7, 5, 8, 4, minus 3. This part is this, and then have 1, 0, 8, 4, plus 2. This part in here, 1, 0, 7, 5, 1, 0, 7, 5. 7 times 5, 7 times 4 is 28, minus 8 times 5 is 40, minus 3. 1 times 4 is 4, minus 8 times 0 is 0. Plus 2. 1 times 5 is 5, minus 7 times 0 is 0. Plus 6, 0. 28 minus 40 gives us 40, 28, 2, 12. That's minus 12. I'm sure 28 minus 40 is minus 12. Minus 3 times 4 minus 0 is 4. 4 times minus 0 is minus 12. Plus 5 minus 0 is 0. 5 times 2 is plus 10. And 0 minus 12 is 0. Minus 12 plus 10. Minus 12 plus 10 equals to minus 2. So this is the determinant of this matrix. These 2 is 6, 7, 2, 2, 2, 1, 1, 2. That's 3. Okay, next elimination goes 2, 2, 1, 2, minus 2. First row and second row is 6, 7 minutes. 6, 7, 1, 2, and plus 2. First row third column 6, 7, 2, 2, plus 3. 2 times 2, 4. 2 times 1, 2, minus 2. 6 times 2, 12, minus 1 times 7, 7, plus 2. 6 times 2, 12, minus 2 times 7, 14. 3. 4 minus 2 is 2, minus 2. 12 minus 7 is 5, plus 2. 12 minus 14, minus 2. 3 times 2 is 6. Minus 2 times 5 is minus 10. Plus 2 times minus 2 is minus 4. 6 minus 10 is minus 4. Minus 4 minus 4 is minus 8. That's the determinant. Okay. 1 plus cos theta. 1 plus sin theta. 1 minus sin theta. 1 plus cos theta. 1, 1, 1, 1. And this is equal to 1 plus cos theta is positive So first row, first column, 1 plus cos theta 1 over minus 1 plus sin theta. First row, second column, 1 minus sin theta 1 1 plus 1. First row, third column, 1 minus sin theta 1 plus cos theta 1. Let's look for the determinants. One plus cos theta 1 minus sin theta times this will give us 1 minus sin theta. Oh, we're supposed to start from here, so we start from here. 1 plus cos theta times 1 gives us 1 plus cos theta minus 1 times 1 is 1 and minus 1 plus sin theta. 1 minus sin theta times 1 gives us 1 minus sin theta minus 1 times 1 plus 1. And this side plus 1 plus 1 plus 1. 1 minus sin theta times 1 is plus 1 minus sin theta minus 1 plus cos theta times 1 minus 1 plus cos theta. So let's evaluate this part. This part first of all. From here, 1 plus 1 plus 1 plus cos theta 1 plus cos theta 1 plus cos theta minus 1. So this will give us 1 plus cos theta. Let's open this bracket. 1 plus cos theta minus 1 plus 1 minus 1 will eliminate. We have 1 plus cos theta times cos theta. So 1 times cos theta will give us cos theta. Cos theta times cos theta will give us plus cos squared theta. So this is the result of this. Simplification of this equals to cos theta plus cos squared theta. The next is, let's evaluate here, minus, and this is out, minus 1 plus sin theta 1 plus sin theta 1 plus sin theta 1 minus sin theta minus 1 minus sin theta minus 1. Okay, already open the bracket, so same thing. So this plus minus will cancel. So I have here minus times 1 is minus 1, minus times plus sin theta minus sin theta, and Here is minus sine theta. Minus 1 times minus sine theta gives us sine theta. Minus times minus is plus sine theta times sin theta gives us sine squared theta. So yield of here is sine theta plus theta plus sine theta. Sine theta plus sine squared theta. Minus 1 times minus sine theta. That's minus sine theta. Okay. Minus sine theta plus sine squared theta. So let's simplify this part. It gives us plus 1 minus sine theta minus 1 plus cos theta. So first of all, okay, and this perfect and close. So let's plus 1 simplify what's in the bracket. 1 minus sine theta. Since separated at minus sine, you open the bracket. 1 minus sine theta. Minus times 1 gives us minus 1. Minus times plus cos theta gives us minus cos theta. So let's open. Let's simplify further. 1 minus 1 minus sine theta minus cos theta. 1 minus 1 minus sine theta minus cos theta. So here we is 1 plus 1 times minus sine theta gives us minus sine theta plus 1 times minus cos theta gives us minus cos theta. So minus sine theta minus cos theta over here gives us minus sine theta minus cos theta. When you run through cos squared minus sine theta plus sine squared theta. Okay, we'll check here. Cos theta plus cos squared theta minus 1 times minus sine theta, so it's plus sine theta minus sine theta times minus sine theta will give us plus minus times minus plus sine theta times sine theta sine squared theta. So it's plus. Okay. We need to check because the procedure is long and we need to ensure that the answers are correct in each of the stages, because your final answer depends on the answer you got in each of the steps or stages undertaken. So, okay, I think I'm check here. Plus 1 minus theta 1 minus sine theta minus 1 minus cos theta. Okay, minus sine theta minus cos theta. So we are good to go. So now that we have arrived at this point, equals to, so here is cos theta minus cos theta. Cos theta minus this cos theta plus cos squared theta plus sine squared theta, and then plus sine theta minus sine theta. Cos theta plus cos theta minus cos theta cancel out. Plus sine theta minus sine theta will cancel out. So we have cos squared theta plus sine squared theta. So from identities, cos squared theta, from identities, cos squared theta, and then cos squared theta plus sine squared theta equals to 1. So our answer therefore is 1 is our final answer. So the determinants of this matrix 1 plus cos theta, 1 plus sin theta, 1, 1 minus sin theta, 1 plus cos theta, 1, 1, 1. The determinant is 1. And so, given that 1, 0, 1, 1, x, 0, 0, minus 1, 1, equals to 2. Find x. So let's get the determinant of this matrix. Plus 1, first row, first column, x, 0, minus 1, 1, minus 1. First row, second column, 0, 1, minus 1, 1, and plus 0. First row, third column, 0, 1, x, 0 is equals to 2. Now 1 cos plus 1, x times 1 is x, minus 1 times 0 is 0, minus 1. 0 times 1 is 0, minus 1 times 1 is minus 1. And here plus 0. 0 times 0 is 0, minus x times 1, x equals to 2. X minus 0 is x, x times 2 plus 1 is x. Minus times minus will give us plus, as plus 1. 0 plus 1 is 1, plus 1 times minus 1 is minus 1. Minus 1. Minus 0 minus x is minus x. Minus times 0 is 0. Plus 0 is equals to 2. So x minus 1 is equals to 2. X is equals to 2 plus 1. And x is equals to 3. That's the value of x. On the side, given that I3 is unit matrix of order 3, find I3. If I3 is unit matrix and some order 3, that is 3 by 3 matrix, and unit matrices are 1, 0, 0, 0, 1, 0, 0, 0, 1. The rule is that you go diagonally, you have 1, and in between you have 0, 0, 0. So this pattern in unit matrix. So let's look at the determinants of this unit 3 by 3 matrix. Plus 1, first plus 1 column, 1, 0, then 1, minus 0, first plus second column, 0, 0, 0, 1, plus 0, first row, third column, 0, 1, 0, 0, plus 1, 1 times 1 is 1, 0 times 0 is 0, minus 0, 0 times 1 is 0, 0 times 0 is 0, plus 0, 0 times 0 is 0, 1 times 0 is 0, plus 1, 1 minus 0 is 1, 1 times 1 is 1, 0 minus 0 is 0, 0 times minus 0 is minus 0, 0 minus 0 is 0, 0 times 0 is plus 0, 0 plus is 1. The determinant of unit matrix of order 3 is 1. First row, first column, 9 minus x minus 4, 2, minus 4, 5 minus x. First row, second column, minus 6. Let's just column minus x 2 minus 4 5 minus x plus 2. Let's draw third column minus 6 2 9 minus x minus 4 plus 10 is equals to 0 plus 10 minus x 9 minus x 9 minus x times 9 minus x times 9 minus x times 5 minus x 5 minus x minus 4 times minus 4 give us plus 16 give us plus 16. Okay. Minus x minus is plus 6. Okay. Minus 6 times 5 minus x minus 6 minus 8 minus 4 times 2 minus 8 minus 8. Let's come here plus 2 minus 6 times minus 4 gives us plus 24 minus 2 9 minus x plus 0. So let's simplify this bracket. So come here 9 10 minus x over 9 minus x 5 minus x minus 16 10 minus x 9 times 5 is 45 9 times minus x minus 9x minus x times 5 minus 5x minus x times minus x plus x squared minus 16 10 minus x 45 this is 45 minus 9x minus 5x minus 14x plus x squared minus 16. So open our bracket, 10 minus x, we should have 45 minus 14x plus x squared minus 16. So 45 minus 16 gives us 45 minus 16, 15 minus 6, 9, 3 minus 1, 2, 29, to 10 minus x, give us this 29 minus 14x plus x squared. So when you multiply, expand 10 times 29 is 290. 10 times minus 14 minus 140x. 10 times plus x squared will be 10x squared minus x times 29 minus 29x minus x times minus 14x give us plus 14x squared minus x times plus x squared give us minus x raised to the power of 3. So minus 140x minus 29x that will give us minus 169x. So this is 290 minus 169x plus 10x squared. 10x squared plus 14x will give us 24 plus 24x squared minus x raised to the power of 3. So this whole part is equal to this part. 290 minus 169 169x plus 24x minus x raised to power 3. So let's simplify this part. So here we have plus 6x plus 6 minus 6 9 minus x minus x minus is plus 8 plus 8. The plus 6 minus 6 times 5 is minus 30 minus 6 times minus 6x plus 6x plus 8 plus 6. Okay, minus x plus 8 will give us minus 22 plus 6x plus 6 times minus 22 22 times 6 2 times 6 12 times 6 plus 1 132 minus 132 plus 6 times plus 6 plus 36x. Okay. Put it here, minus 132 plus 36x. So we move over to this part of the expression. So plus, let's do it here, plus 2 24 minus 2 9 minus x, okay, plus 2 24 minus 2 times 9 18 minus 2 times minus x is plus 2x, and this will give us 2 24 minus 18 24 minus 18 14 minus 86, that's 6 plus 2x 2 times 6 12 plus 4x plus 12 plus 4x equals 0. So, okay, so let's collect our like terms. CLT 290 minus 132 plus 12 and minus 169 minus 169x plus 36x plus 4x plus 4x plus 24x squared 24x squared plus 24x squared minus x raised to power 3 equals to 0. Let's see. One seventy minus 129x plus 24x squared minus x equals to 0. Now we have a polynomial where the highest power is greater than 2. The highest power here is 2 and it's greater than 2, so we are going to solve it in the way we solve a polynomial. And that way we are going to get, first of all, a factor. So this polynomial has 3 factors or 3 roots. So we need to get one of the roots. To do that, we're going to carry out the trial and error method. So we're going to say fx is equals to 170 minus 129x plus 24x squared minus x raised to the power 2 is equal to 0. So let's try x minus 1. If you try x minus 1, let's try x minus 1 equals to 0. X minus 1 is equal to 0. It implies that x is equal to 1. So put 1 in place of x here. So f1 equals to, so anywhere we see x in this expression, we're going to put 1 in place of it. 170 minus 129, 1 plus 24, 1 squared minus 1 raised to the power 3. If it's equals to 0, that means x minus 1 is a factor of this polynomial. So let's say what that gives us. This is equal to 170 minus 129 plus 1 raised to the power 2 is 124. 1 raised to the power 3 is 1. And this will give us 170 minus 129 129 plus 24 minus 1, that's 64. So that means that x minus 1 is not a factor. Therefore, x minus 1 is not equals to 0. It's not. So it's not. It is not a factor. Let's try x minus 2. Let's try x minus 2 equals to 0. So x minus 2 is equal to 0 implies that x equals to 2. So f2 is equals to 170 minus 129, 2 plus 24, 2 raised to the power 2 minus 2 raised to the power 3. 170 minus 258 plus 24 times 2 raised to the power 2 is 4. 4 times 24, 96. 96. 2 raised to the power 3 is 8 minus 8. So this will be equals to 0. What this implies is that therefore x minus 2 is a factor of fx, where fx is this polynomial that we got, this polynomial. What we're going to do next is to divide this polynomial by this factor. But before we can do that, we write fx as, we want to ensure that highest power comes first whenever we are dividing the polynomial by this factor. So this will give us minus x raised to the power 2 because x negative coefficient is minus 1. Then followed by plus 24 x squared, followed by minus 129x minus 129x, followed by plus 170 plus 170. So we can, okay, next is divide fx by x minus 2. So x minus 2 gives us minus x raised to the power 2 plus 24x squared minus 129x plus 170. So x divided by minus x raised to the power 2 will give us minus x raised to the power 2. So minus x raised to the power 2 times x will give us minus x raised to the power 2. Minus x raised to the power 2 times minus 2 will give us minus x minus is plus 2x squared. We're going to subtract. When we subtract, minus x minus is plus. Minus x raised to the power 3 plus x raised to the power 3 is 0. Minus x plus is minus 24x squared minus 2x squared gives 22x squared. 22x squared, so we'll bring down minus 129x, and then we continue our division. X into 22x squared will give us 22x plus 22x. Now we multiply. Plus 22x times x will give us 22x squared plus 22 times plus 22x times minus 2 will give us minus 44x. So we subtract. Minus x minus will give us plus. Of course, this is 0 already. Minus x minus plus. Minus 129 plus 44. Minus 129 plus 44. Minus 85. Is minus 85x. So bring down our 170 plus 170. So x into minus 85 gives us minus 85. Minus 85 divided by x divided by x will give us minus 85. Minus 85 times x will give us minus 85x. And minus 85 times minus 2 will give us plus 170. And when you subtract, minus times minus is plus. Minus 85x plus 85x is 0. And minus times plus is minus. 170 minus 170 is also 0. So at this point, the factors of therefore x minus 2 and minus x squared plus 22x minus 85 are factors of fx, which is this polynomial. Fx is this polynomial. So next thing I'm going to do is factorize this quadratic factor of the polynomial. We're factorizing minus x squared plus 22x minus 85. The factors of these minus 85. Let's do it here. Let's here minus x squared plus 22x minus 85. So multiply the AC, which is the coefficient of x squared, or x squared times AC will give us minus 85 squared. So minus 1 times minus 85 will give us plus 85x squared. And the two factors of 85 are 5 and 17. So since AC is positive, and A plus C, which is a sum, is also A plus B is positive, it shows that the two factors are positive. Plus 5 times plus 5x times plus 17x will give us plus 85x squared plus 5x plus 17x give us plus 22x. So we put all of these factors in here. So minus x squared plus 5x minus 17 plus 17x plus minus 85 minus x squared plus 5x have here 17x minus 85. Minus x is common. X minus 5 is 17. X minus 5. So bring out, we have minus x plus 17, x plus 17, and x minus 5. Minus x plus 17 can also be written as, this is equals to 17 minus x and x minus 5. So it's a factorized form. So I'm going to put this here. So factorizing, do it here again. So minus x squared plus, remember our factors, 5x and 17x plus 5x plus 17x minus 85 is equals to, since we're only factorizing this part, we're not equating to 0. So we're going to have minus x squared plus 5x close the bracket and 17x minus 85. Minus x is common, x minus 5 and plus 17. We have x minus 5 also. So this is minus x plus 17 and x minus 5, which can also be written as, since x negative and this is positive, 17 minus x and x minus 5. So these are the factors of the quadratic expression, and alongside this factor are the three factors of this polynomial. So the roots of this polynomial will give us the determinant of this 3 by 3 matrix, of course, which is the value of x, because I think the value of x. Yeah. So therefore fx equals to x minus 2, x minus 2, x minus 5, and 17 minus x. Therefore, x equals to, if you equate each of these factors to 0, their values will be x equals to 2. Let's say x minus 2 is equals to 0, x minus 5 is equals to 0, and 17 minus x equals to 0. And here x is equals to 2, x is equals to 5, and minus x is equals to minus 17, and x is equals to 17. Therefore, x equals to 2, 5, or 17. 2, 5, or 17. So expand the determinant. A part A says we should expand its determinant to give us a polynomial as fx, x minus 2, x minus 2. First row, first column, x minus 3, minus 2, minus 1, x minus 2. Minus 2, minus 2. First row, second column, minus 1, minus 1, minus 1, x minus 2, and plus minus 1. First row, third column, minus 1, minus 1, x minus 3, minus 2. Okay. So here, x minus 3 times x minus 2, x minus 3, x minus 2, minus 2 times minus 1 is plus 2. And here, minus times minus is plus 2, plus 2. The minus 1 times x minus 2 minus 1, x minus 2, minus 1, x minus 2, and minus 1 times minus 1 minus 1 times minus 1 will give us plus 1. Then plus times minus is minus 1. Minus 1. Minus 1 times minus 2 is 2. Minus 1 x minus 2 times minus 1 will give us minus 1. Okay. Since it's 1, we can omit it. Minus 1 x minus 2 x minus 2 is minus x minus 2. We can also omit this 1 here. It's still the same. So it still is minus 1. So the first thing first, let's simplify all of these parts. And here, x minus 2, x minus 3, x minus 2, minus 2, x minus 2, x times x is x squared, minus 2x minus 3x plus 6, minus x minus 3, x squared, minus 2x minus 5 minus 5x plus 6, minus 2, x minus 2, open a bracket, x squared minus 5x plus 6, minus 2, x minus 2, x squared minus 5x plus 6 minus 2 plus 4. So we expand x times x squared, x to the power 3, x is minus 5x minus 5x squared, x times plus 4 plus 4x minus 2 times x minus 2x squared minus 2 times minus 5x plus 10x minus 2 times plus 4 minus 8 x to the power 3 minus 5x squared minus 2x will give us minus 7x squared plus 4x plus 10x plus 14x and minus 8. So all of this will give us this. So x raised to the power 3 minus 7x squared plus 14x minus 8. Let's simplify this part. Plus 2 plus 2 minus x minus 2 minus 1 plus 2 minus x minus x minus x minus 2 plus 2 minus 1 minus x plus 2 minus 1 is plus 1. So open expand minus 2 times minus x is plus 2x minus 2 plus 1 plus minus 2. So this give us plus 2x minus 2. Finally, let's simplify this part. So minus 1, 2 minus x minus 3 minus 1, 2 minus x plus x plus minus x plus x will give us 2 minus x plus x will give us minus x minus 3 plus 3 minus 1, 2 minus x minus x plus x minus x plus 3 minus 3 minus 1. Okay, obviously 1 is still the same thing. 2 plus minus 3 minus 1 plus x minus x minus 1 is equal to plus 1 minus x plus x minus x. So plus 1 minus x. Now x raised to the power 3 minus 7x plus 14x plus 12 is 16x minus x give us 15x minus 8 minus 2 minus 10 plus 1 minus 9. So as usual, let's make sure I can run through before I proceed. So this part here is from here, x squared minus 7x squared plus 14x minus 8, 5x squared plus minus 5x minus 7x squared plus 4x plus 10x plus 14x minus 8 squared yes plus 2 plus 2 plus x plus 2 minus 2 this plus 2. Sorry about that. Because of why calculating, I mistakenly minus 2 here. So meaning that answer here is going to be affected. So here is plus 2 plus 2 times minus x minus 2x plus 2 times plus 1 plus 2, which can also be written as 2 minus 2x. So 2 plus 2 minus 2x. So let me check this other part here. Is it okay? Minus 1, so yeah, minus 1, 2, minus x minus x minus x minus plus 3 minus x minus x plus x minus x plus 3 minus 3. So 2 minus 3 minus 1 plus x plus 1 minus x plus 1 minus x for x. X is equal to minus 7x squared plus 14x. Okay, plus 14x minus 2x give us 12 plus 12x plus 12x minus x will give us plus 11x minus 8 plus 2 minus 6 plus 1 plus minus 5. That's all. So this is the expanded determinant. That's A, expanded determinant. So this is the expanded determinant. So B says find the zeros of fx in A. So this is a polynomial fx is equals to x raised to the power 2 minus 7x squared plus 11x minus 5. That's the polynomial. So to get zeros means get the roots. To get the roots of this polynomial, we are going to get the factors of this polynomial. So the first thing we're going to do, we're going to try some factors. Let's try x minus 1 equals to 0. So this implies that x equals to x minus 1 equals 0 implies that x is equals to 1. So f here you have x. Since x equals to 1, you put 1. So this means anywhere in this expression, anywhere there is x, you put 1 in place of x. In place of x. So 1 is equal to 3 minus 7. 1 raised to the power 2 plus 11. 1 minus 5. 1 raised to the power of 3 is 1. 1 raised to the power of 2 is 1. 1 times minus 7 is minus 7. 11 times 1 is plus 11. And then minus 5. 1 minus 7 is minus 6. Minus 6 plus 11 is minus 6 plus 11 is 5. And 5 minus 5 is 0. So this implies that therefore x minus 1 is a factor. X minus 1 is a factor of fx. Next, divide fx by x minus 1. So since polynomial is already in the right form where x the highest power is the first number if you're starting from the left, you don't need to rewrite it. So x minus 1, so x raised to the power of 3 minus 7x squared plus 11x minus 5. That's 11x minus 5. So x into x raised to the power 2 is x squared. X squared times x is x raised to the power 3. X squared minus 1 is minus x squared. We subtract x raised to the power 3 minus x to the power 3 is 0. And then x minus is plus. So minus 7x squared plus x squared will give us minus 6x squared. Bring down 11x plus 11x. Next thing, we divide x. 6x squared minus 6x squared divided by x will give us minus 6x. Minus 6x times x will give us minus 6x squared. Minus 6x times 1 is plus 6x. We subtract. Minus x minus is plus. Minus 6x squared plus 6x squared is 0. Minus x plus is minus. 11x plus 6x is 5x. Bring down your minus 5. So 5x divided by x will give us plus 5. Plus 5 times x is 5x. Plus 5 times minus 1 minus 5. We will subtract. 5x minus 5x is 0. Minus x minus is plus. Minus 5 plus 5 is also 0. So our other factor is x squared minus 6x plus 5. Next, factorize. Next, factorize the quadratic expression of this other factor. Oh, okay. Therefore, we can say, therefore, the factors of fx are x minus 1 and x squared minus 6x minus 6x plus 5. So we're going to, next thing is we're going to get the factors of this quadratic part. So let's say next, factorize x squared minus 6x plus 5. We call here x squared minus 6x plus 5. This will give us 5x squared. Factors of 5 are 3 and 2. 3 or no, not 3 and 2. Factors of 5 are 5 and 1. So this will give us 5 minus 5x times minus 1 or minus x is equals to plus 5x squared minus 5x minus x equals to minus 6x. So this satisfies what we have here. So we'll put all of this in place of minus 6x. This will give us equals to x squared minus 5x minus x plus 5. So this is equals to x squared minus 5x and minus x plus 5. The x is common, x minus 5, and then minus 1, x minus 5. X minus 1, x minus 5. So there are two factors of the polynomial fx are x minus 1 and x minus 5. Therefore, the factors of fx are x minus 1, and this x minus 1 and x minus 5. To get the zeros, equate each of them to 0. The zeros of fx are gotten as follows. So x minus 1 is equal to 0, which also implies that x is equal to 1, and this one x minus 1 is equal to 0, which implies that x equals to 1. And here, x minus 5 is equals to 0, which also implies that x equals to 5. Therefore, zeros or roots of fx is equals to 1, 1, 1, 5. Or we could say the zeros are zeros of fx. Zeros of fx is equals to 1 twice 1 twice comma 5. That's it. Find the non-zero positive value of b, which satisfies the equation b 1 0 1 b 1 0 1 b equals to 0. So these determinants, so plus b, first row, first column, b1, 1, b minus 1, first row, second column, 1, 0, 1, b plus 0, first row, third column, 1, 0, b 1 equals to 0. So plus b times b is b squared. 1 times 1 is minus 1. Minus 1. Minus 1. 1 times b is b. 1 times 0 is 0. Plus 0. 1 times 1 is 1. Minus 0 times b is 0. It's 0. So b squared minus 1. b minus 0 is 0. b minus 0 is b. b times minus 1 is minus b. So 1 minus 0 is 0. 1 times 0 times 1 minus 0 is 1. 1 times plus 0 is 0. Plus 0 plus 0. So this is b squared minus 1 minus 1. B squared minus 1 minus b equals to 0. So b times b, you can do it in two ways. You can say, okay, first way is b times b squared, b raised to power theory. B minus 1 minus b that's equals to 0. So b raised to power theory, b minus b minus b equals to minus 2b is equal to 0. So let's factor out the common factor. So b is common, so b squared minus 2 that's equals to 0. So either b is equals to 0 or b squared minus 2 is equals to 0. So b squared is equals to 2. Take square root of both sides. Take square root of both sides. And both sides. Our value will become b squared square root of b squared is equals to square root of 2. So you cancel. So b is equals to 2. Final answer. Or we don't do it that way. We can just from here, from this part here, b. Let me take from this part b squared minus 1 minus b plus 0 plus 0 is equal to 0. So b squared minus 1 minus b is equal to 0. b squared minus 1 brings 1 to this side becomes plus b. Look, here, divide both sides by b squared minus 1 is equals to b over b. B squared minus 1 is equal to b here 1, b here 1. That will be 1. So b squared is equals to 1. This one moves over to the side. B squared is equals to 2. So take square root of both sides. Take square root of both sides. Root b squared is equals to square root of 2. Okay. Square root of 2. These two cancel square root side. So b is equals to root 2. Find the value of k if minus 2, 2, 1, 1, 1, 3, 1, k minus 1 equals to 23. So this is plus minus 2, 1, 3, 3, minus 1, minus 1, 2, 1, k minus 1, and plus 1, 2, 1, 1, 2. Plus x minus is minus equals to plus 2 into 2. So plus x minus is minus 2. 1 times minus 1 is minus 1. Minus 3 times 2 is 2k minus 1. 2 times minus 1 is minus 2. K times 1 minus k plus 1. 2 times 3 is 6 minus 1 times 1, 1 plus 22. Minus 2 times minus 1 is 2. Minus 2 plus minus 3k is plus 6k. Minus 1 times minus 2 is plus 2. Minus 1 times minus k is plus k. Plus 1 times 6 minus 1 is 5. Plus 1 times 5 is plus 5, which is equal to 23. 2 plus 2, 4. 4 plus 5, 9. 6k plus k. So that's 7k equals to 23. 7k is equals to 23 minus 9. 23 minus 9. 12 minus 9 is 12 minus 9 is 4. 12 minus 9. 30 minus 9 rather is 4. Then 1, that's 14. So 7k is equal to 14. And k is equal to 14 over 7, which is equal to 2. That's the value of k. Three x minus 3, 5, 2, minus 4, 2, minus 4, 3, 2, 6 minus x is equal to minus 24. So x minus 3, 2, minus 4, 2, 6 minus x. Minus 4, 5, 2, 2, 6 minus x plus 3, 5, 2, 2 minus 4 plus minus 24. X minus 3, 2 times 6 minus x gives us 2, 2, 6 minus x minus 2 times minus 4 minus 8. Minus times minus is plus 4. 5 times 5, 6 minus x. 5 times 6 minus x. And 2 times 2 minus 4. Okay, plus 3. Plus 3. 5 times minus 4 minus 20. 2 times 2 minus 4 plus minus 24. So let's simplify this part. Let's simplify this part. From here 2 times 2 times 6 will give us 12 minus 22x. 5 times 12. Minus times minus is plus 8. So 12 plus 8 is 20 minus 2x. And then multiplied by x minus 3. X times 20, 20x. X times minus 2x minus 2x squared. Minus 3 times 20 minus 60. Minus 12 minus 2x plus 6x. 20x plus 6x will give us minus 2x squared plus 26x minus 60 minus 2x squared plus 26x minus 60. Come to this side, plus 4, 5 times 6x, 5 times log is plus 4, 5 times 6 will give us 30, 5 times minus x minus x minus 4. So 30 minus 4 plus 4, 30 minus 4 is 26 minus 5x plus 4 times 26, 26, 4, 4 times 6, 24, 4 times 6, 8 plus 2, 10, 104, 104, 4 times minus 5 minus 20x plus 104 minus 20x. Okay, side. Plus 3 minus 20 minus 4 minus 24, 24 times 3, 3 times 4, 12, 3 times 6 plus 1, 72. Minus x plus is minus 72. Minus 72. We will write it again. Plus minus 2 x squared plus minus 2 x squared plus 26x minus 60 plus 104 plus 104 plus minus 2x squared plus 26x minus 60 plus 104 minus 20x minus 72 equals to minus 24 minus 24 minus 2x squared plus 26x minus 20x will give us plus 6x minus 60 plus 144 minus 72. Let's do first. Let's do it here. Minus 60 minus 72. 60, 72. Since the signs are the same, we add 0, 2, 6 plus 7, 13, 133. Then we put our negative side. So minus 60 minus 72 plus minus 132 plus 104 plus 104. 34. When the signs are different, you subtract. 12 minus 4 is 8. 2 minus 0, so that's 28. So minus 28. Minus 28 equals to minus 24. We can rewrite this by multiplying through by minus 1. This will give us minus 2x squared plus 6x minus 28 plus minus 1 minus 24. Okay, so this will give us minus x minus will give us plus 2x squared minus 6x squared minus 6x minus x plus 6x will give us minus 6x minus x minus 28 plus 28 equals to 24. Well, since we are going to get the values of x, we need to make sure that it's equals to 0. 2x squared minus 6x plus 28 raised over plus minus 24 is 0. So 2x squared minus 6x 28 minus 24 will give us minus 4, so 0. Can reduce this by dividing through divide through 2. So this is x squared minus 3x minus 2 equals to 0. Now we're going to look for the factors of x squared minus 2x. X squared minus 3x minus 2. This will give us minus 2x squared. So minus 2x times minus x times plus x will give us minus 2x times plus x will give us minus 2x. So minus 2x plus x will give us minus 2x plus x will give us sorry, here it's supposed to be plus 28 minus 24 is supposed to be plus, yes, plus 2. It sounds finding it's difficult. I see that if that is minus, we might not be able to factorize, so I have to look at that part again to see if there's a mistake. And I figured out that instead of writing plus 4 here, I wrote minus 4 initially, because plus 28 minus 24, you're subtracting a lower number from a bigger number, so it's going to be plus 4, not minus 4. So let me rewrite it again. So our equation is x squared minus 3x plus 2. So when you multiply, you're going to have 2x squared. So if we go by minus 2x squared minus 2x squared minus 2x times minus x will give you plus 2x squared minus 2x minus x equals minus 3x. So this satisfies what we have here. Plus 2x squared, which is what we have here, minus 3x plus 2x squared is AC, the product, this area, and then minus 3x is the sum, which is what we have here. So these two factors will give us this, which satisfies the product expression. So we'll put this, everything, all of these in place of minus 3x in this equation. So x squared minus 2x minus x plus 2 equals to 0. So x squared minus 2x and minus x plus 2 equals to 0. X minus 2 and here minus 1 equals x minus 2 equals to 0. So x minus 1 and x minus 2 equals to 0. Either x minus 1 equals to 0, which implies that x equals to 1, or x minus 2 is equal to 0, which also implies that x equals to 2. Therefore, the values of x are the values of x are 1 and 2. Well, we can see, therefore x equals to 1, 2.